Class 7, we are doing the same exercise 1 of algebra, objective part number 2, true and false. So here you have to mention which statement is true and which statement is false. The first statement, many relations of arithmetic may be expressed as general formula by alphabetic symbols. Now definitely yes. Now suppose arithmetic relations. Suppose if I say 2 plus 4 gives you 6. It is an arithmetic relation because you have used number, you have used addition sign. So this is an arithmetic symbol and numeric numbers, and 2 plus 4 equal to 6. Now in the same way, 3 plus 3 also gives you 6. This is also an arithmetic relation. So not only 2 plus 4 gives you 6, 3 plus 3 also gives you 6. So can we write in alphabetic form that sum of two numbers equal to 6? It can be anything. Either I have taken the two numbers 2 plus 4 or I have taken the two numbers 3 plus 3. But both of them gives me 6. So in general, I can express the relation in algebraic form by using the alphabets, that sum of two numbers x and y is equal to 6. So this x can be anything, y can be anything, but here we are using symbols x and y, alphabetic symbols, as two numbers, and when they are added they are giving the value 6. So the statement is true. Yes, that many arithmetic relations without using the numbers, I can show it in alphabetic by using alphabetic symbols. B. If x be a natural number, now natural number means 1, 2, 3, 4, anything, then 2x is always an odd number. That means if you multiply 2 to x, it will always give you an odd number. Now let us take x is equal to 1. Now see what happens. When you do 2x, that means 2 is multiplied to x. So 2 into 1, it gives you 2. Suppose instead of x is equal to 1, I am taking x is equal to 2. Now if I find 2x, it means 2 into 2 now, because x value is 2. I am just doing value putting and I am finding what will be the value of 2x. If the x value, whatever it is, if multiplied to 2, so it is giving me 4. Suppose x is equal to 3. Then what is happening? We will find the value of 2x by doing value putting. We will put the value of x. So 2 into 3 gives you 6. Now what you can observe, x can be any natural numbers, 1, 2, 3, anything. It can be odd numbers or even numbers. But when you find the value of 2x, it will always give you an even number as the result. See, 2, 4, 6 is coming. That means with any natural number, if you multiply 2, that always gives you an even number. So the statement over here is false. Because if x is any natural number, if you multiply 2 to that natural number 2x, it will always give you an even number and not an odd number. Now number C is almost like this. But here the question is somewhat different. If x be the natural number, then 2x plus 1 will always be an odd number. Now I will just ask you to see what is the difference between the previous and this sum. Here they are asking that 2x will be odd number or even number. Here they are asking that what will be 2x plus 1. That means if I find the value of 2x plus 1, will it give me an odd number? So when x is 1, your 2x value is 2. And if you do 2x plus 1, it will give you 2x value came 2. So 2x plus 1 will give you 3. So I am just showing with the help of the previous sum that I have done. When x is equal to 2, x is any natural number over here. Here also x is any natural number. So what is the 2x value? It is always even number 4. And what will be 2x plus 1 value? 4 plus 1, 5. Similarly, if x is equal to 3, a natural number, 2x, if you multiply, if you put the value of x, the 2x value will be an even number. And with that, if you add 1, it will be an odd number. So, if x is a natural number, then 2x plus 1 value will always be an odd number. So, this will be true. The last question, if x is not equal to y with equal to sign, if a cancellation sign on top is given, it means not equal to. Then always x is greater than y. So they are asking you that if x is not equal to y, that means x is a number 2 and y is some other number, suppose 4. So if they are not equal, then will it be the result that x will always be greater than y? Now not equal to means they are not same, but the number can be greater than or less than. So x can be greater than y or it can be even less than y. Then also they are not equal, the statement holds true. So whenever any two numbers are not equal, it does not mean that x will be always greater than y. It can also be that x is less than y. But in both the case, x and y are unequal. So this statement is false. So if they are not equal, it does not mean that x is always greater than y. It can also be the value of x is less than the value of y. In both the cases, we can say that x and y are unequal. Number E. What is given? X is less than. This sign means less than or equal to. That means x value is either less than the value of y or it can be equal to the value of y. Okay, suppose if I say y equal to 5. So x has to be less than y value. That means x can be anything, but it has to be less than the y value, which is 5. So x can be 1, 2, 3, 4, anything. And this sign means x can also be equal to y. That means what are the numbers that x can take? X can be less than y, so it can be 1, 2, 3, 4, any number. And x can also be equal to y, so it can be even 5. So x can take so many values. On the other hand, what is given? X is greater than y. And it is asked, are they same? That means both these notations or algebraic expression, do they have same meaning? So here x greater than y means y is 5. So x has to be greater than y means x value can be 6, 7, 8, but it has to be strictly greater than the y value 5. So are these matching? No. Here x is less than equal to 5, y means if the value of y is 5, let us take it, then x can take all the values which are lesser than 5 or equal to 5, because x can also be equal to y value. But on the other hand, the result is contradicting. x is greater than y. That means x can be any number, 6, 7, 8, 9, 100, anything, but it has to be greater than y value. So they don't have the same meaning. So it is false. Next question. Since mn equal to m into n, therefore 62 equal to 6 into 2. So here algebraic expression is given. In algebra, mn, what does it mean? M is multiplied to n, or we also call m times n, or we multiply m into n, and the result is mn. So in algebra this is possible. Mn means m is multiplied to n. But in arithmetic, does 62 mean 6 into 2? No. What does it mean? 60 plus 2. 62. Or you can say 6 into 10 plus 2. If I break it further, 60 means 6 into 10 plus 2. So the number 62 means the first digit is in tens place. So it is 60 plus 2 is in its units place. And this 60 can be written as 6 into 10 plus 2. So definitely the arithmetic expression and this algebraic expression, they are not matching. So they are false. It does not mean that in algebra, if we multiply and write mn as m into n, it does not mean that arithmetic, the numbers can be written 62 as 6 into 2. Then the next part, G. 5 years ago, your age was X years. So 5 years before, so now your age, whatever it is, 5 years before it was X years. So what will be your age now? You have grown 5 years older, so it is X plus 5. Then after Y years, what will be your age? Will your age be X plus 5 plus Y? Definitely true, because before 5 years your age was X, now your age is X plus 5. Now after Y years, what will happen? Your age will add on by the number of years Y. Suppose if I tell after 4 years what will be your age, so with your present age you have to add 4 years. Similarly, after Y years what will be your age? With your present age, you have to add the number of years told in the question. So definitely your age is going to be X plus 5 plus Y years, and so the statement is true. Age. The age question is similar but opposite to the one which you have done before in this true and false section. As 75, this is an arithmetic number. Now 75 means 7 is in the tens place and 5 is in the units place. So it is 70 plus 5, or you can say 7 into 10. With the first digit you need to multiply to get 70, plus in the units place you have 5. So it is true, because in arithmetic any number, 2-digit number, if you take, how do we read it? 75, we read it as 75. That means 70 plus 5. And if I break further, it means 70 means 7 into 10 plus 5. So with the first digit, since it is in the tens place, we multiply 10, plus 5 is in the units place, we multiply nothing, means we are multiplying 1 to it. But do the same form can you apply in algebra? That means xy means, since the first digit is x, that means x, it is in the tens place, so you can write it as x into 10, plus y is in the units place, so can you write like this, x into 10 plus y, just like the arithmetic form? It is no, because in algebra simple xy means x is multiplied to y. So as 75 equal to 7 into 10 plus 5, therefore you cannot say that xy means x into 10 plus y. So this is false. The next one, the relation given that there are two numbers a and b. Now what is said? A is greater than b or a is less than b. That means either a is bigger than the value of b or a's value will be less than b. So suppose if I take b equal to 10, either a is smaller than b, so a can be 1, 2, 3, 4 till 9, or it is greater than b means a can be 11, 12, 13, 14, anything. So a's value should be either greater than b means either greater than 10. If I take b's value is 10. So a can be anything like 11, 12, 13, 100, 1200, anything. But it is greater than b's value, or a is less than b. So if b is 10, a can be anything like 1, 2, 3, 4, 5 till 9. Now can it be represented means can it be written as a not equal to b? Now definitely it can be written, because what it is telling you, either a will be greater or a will be less than b, but anytime they won't be similar. That means a's value and b's value will not be equal. So it is written with a not equal to sign. So it is true. And the last question of true and false. If x be an odd number, so it can be any odd number. Let us take x is equal to 3. Then the odd number succeeding x. Succeeding means which comes after. So if x is equal to 3, they are asking you how will you get the next odd number. So after 3, what is the number? 4. And then you get the next odd number 5. So 3 plus how much gives you 5? 3 plus 2 gives you 5. So x value is 3, and with x if you add 2, then only you will get the next odd number. Because if you see the number series 1, 2, 3, 4, 5, the even numbers, they occur at an interval. 2 plus 2 gives you 4, plus 2 gives you 6. Similarly, odd numbers also occur at interval 1, 3, 5. So 1 plus 2 gives you 3, 3 plus 2 gives you 5. So if you want to get the next odd number, if x is an odd number, suppose any odd number you can take, I have taken 3, then how will you get the next odd number? Will you get by adding 1 to x? No, because if you add 1, you get the 2x value. X is an odd number. So if I add 1, I will get the next even number. But if I add 2, then only I will get the next odd number. So this will be false. So x plus 2 will give you the next odd number, but x plus 1 gives you the next even number. So till here, you will copy the part in your classwork copy. Exercise 1, part 2, true and false.